what we have to show? That tangents at the ends of a lattice system of an ellipse intersects on the major axis. So at first, we take a standard ellipse. Let equation of the ellipse consider be x square by a square plus y square of b square equal to 1, which we mark as equation 1. And we have taken in such a way that here a greater than b, so that we can see the major axis of the ellipse is along the x-axis. So we have taken x square by a square plus y square by b square equal to 1. Here a greater than b, that means the major axis along x-axis. Now we draw the ellipse. We draw the ellipse here. This is y, this is x prime, this is x, this is origin, this is y. So this is the ellipse considered. Now the tangents are to be drawn at the end points of lattice system. So we take here our lattice system. L1, L4. This point is a comma b square by a, and this point is a comma minus b square. So this is the equation, this is the ellipse given, whose vertex can be considered as a comma 0 and a prime minus a comma 0. So here the tangents are to be drawn at the end points of the lattice system, of our lattice system. So we have the equation of the ellipse. So you can find the tangent at this point. We can find the slope of the tangent at this point. How? We know the slope of the curve at the point L1 equal to slope of the tangent at this point. So when you draw here a tangent at the point L1, we to find the equation of this tangent, which we mark as, which we take as L1. We have the point of contact, just we need the slope. So first of all, we differentiate this curve and try to find the slope at this point. So on differentiating equation 1 with respect to x, we get dx of y equals to minus b square x by a square y. So you get here that is b square x by a square y. So that is the, after getting the derivative of this one, this function, this equation, we get this one. On differentiating this equation, we get this. Now we need to get the equation of this tangent. We need the slope of the curve at this point, which is equal to slope of the tangent at this point. So slope of the tangent L1t at L1, which is a comma b square by a, is given by dx of y at a comma b square by a. Now we substitute here the value and we get minus b square into a by a square into y. Y is here b square by a. Now this one simplification gives us minus e as a slope. Therefore, equation of L1t is y minus y1 equal to minus e into x minus x1. Now this one further simplification gives us ex plus y equal a is square plus b square by a. Now we can simplify this one further and write ex plus 1 equal a square e square plus b square by a. Now we know b square equals to a square to 1 minus c square. So from that we write this one equal to a square by a, that is a. Y as b square equal to a square into 1 minus c square. Now therefore equation of L1T we get ex plus y equal to a, which we mark as equation 2. Now this is the equation of L1T. Now similarly we can find the tangent at L4. So when we find the tangent at L4, we need the slope of the curve at the point L4, that is the equal slope of the tangent at the point L4. So slope of the curve at L4 equal to slope of tangent at L4. That is ddx of y at L4, which is a comma minus b square by a. That is minus b square into a by a square into y. You have taken the minus already, and here the substitute by a b square by a, and we get here e. Now we got here the slope. Now once we got the slope, we can find the equation. So equation of the tangent at L4 is y minus y1 slope into x minus x1. Now this on simplification will give us ex minus y equal b square a plus a square. Now this one simplification gives us b square plus a square by a. Now this one further simplification ex minus y equal to a, and this we mark as equation 3. We have used here the same value of b square which we have already used here, and we got this one. Now solving equation 2 and 3. On solving equation 2 and 3. This is basically we are adding here equation 2 and 3. So we get here x equals to a by e. Just if we add these two equations, we get twice ex equal to twice a, so x is a by e. And once we substitute here the value of x in the equation 2 or 3, if we substitute here into 2 also, e x will be equal to a, so y will be a minus a, that's 0. So from here we get y equal to 0. So definitely here the two tangents intersect at the point a comma 0. So here we can write that the tangents drawn at the end points of lattice rectangle L1 a comma b square by a and L4 a comma minus b square by a intersects at a by e comma 0. Now already we have told here that a greater than b. A greater than b means the major axis is x equal y equal to 0. Major axis is x-axis obviously. Major axis is x-axis which is y equal to 0. So we can say here since from equation 1 major axis is y equal to 0, that is x-axis. So we conclude point of intersection of L1T and L4T lie on major axis. Because a comma 0 means y coordinate is 0, so that definitely lie on the major axis, which is the x-axis. Now same thing can be proved by taking the vertical ellipse also. So anyone will do because you have taken a general. Find the equation of the common tangent to the circle x square plus y square equal to 8 and the parabola y square equal to 16x. So what we say, equation of circle is x square plus y square equal to. So this is the equation of a circle, which we mark as equation 1. Now we have another curve, which is the equation of a parabola. So that is y square equal to 16x. And we have to find the equation of the common tangent. There is a tangent will be tangent to the parabola as well as the circle. So we can imagine how it may look like. Y, x prime, y prime. Now this is the parabola equation. Now the circle. Center is the origin. And we can imagine a tangent like this. This is the common tangent which we can get. Now, for this common tangent, at first we'll find the equation of tangent to this parabola. So at parabola, if we draw the tangent, this is the point of contact. Now the point of contact can be thought as we know, it is y square equal to 4ax. So this can be written as at square comma 2at. Now at square, a is 4, so 4t square plus 8t. Now we have here 40 square comma 80 as a point of contact. Now for after we have got the point of contact, we can find the slope here. So further we differentiate equation 1 to equation 2, and we get here ddx of y equal to 8 by y. Therefore ddx of y 40 square comma 80, so it is 8 by 80, which is 1 by t. Therefore equation of tangent is given by y minus 8t equal to 1 by t x minus 4t square. Now on further simplifying, yt equal to x plus 4t square. Now when these are tangent to this circle also, then what we can say, distance of this tangent from the center is equal to radius. Now we mark this equation 3. Now distance of the circle from the tangent is equal to radius of the circle. Now center of the circle is the origin. So distance from which one? It is ty plus x equal to 40 square. So it is t into 0 plus 0 minus 40 square by root over of 1 plus t square equal to root over of 8. Now from this what we can say, 4t square by root over of 1 plus t square mod of this equal to root 8. Now on squaring both sides, we get 16 to the power of 4 by 1 plus t square equal to 8. Now 2 to the power of 4 equal to t square plus 1. Now this 2 to the power of 4 minus t square minus 1 equal to 0. Now 2 to the power of 4 minus 2t square plus t square minus 1 equal to 0. Now if we simplify this, we get 2t square into t square minus 1 plus 1 into t square minus 1 equal to 0. Now 2t square plus 1 into t square minus 1 equal to 0. Now this part will never be equal to 0. So we have only one condition here, that t can be plus minus 1. Now why plus minus 1? We'll understand, because we'll get here 2 points of contact. T2 is 4 comma minus 8. So we have to substitute the value of t. We have 1t, this one, plus 1, and there is minus 1. That gives us 4 comma 8, and that gives us 4 comma minus 8. Now after that we can find the equation of tangent. Equation of tangent is y minus 8 equal to 1 into x minus 4 and y plus 8 equal to minus 1 here into x minus 4. So these are the two equations we get. This one further simplification gives us y equal to x plus 4, and this one y equal to minus x minus 4. So this is the equation of tangents which we are getting. Common tangents. Now here we understand there are two tangents. The reason is this one. One tangent is possible at this point. One tangent is possible at this point. So these are the reason you have got two tangents. Equation of common tangent to the parabolas. Now there are two parabolas are given. So equation of parabola. Equation of parabola. One is given y square equal to 32x, which is opening on a positive x-axis. We mark it as equation 1. And x square equal to 4y, which is opening on a positive y-axis. And we need here the equation of common tangent. This is x prime origin y x y prime. We take here two parabolas. One is y square equal to 32x, and there is x square equal to 4y. This is x square equal to 4. Now the common tangent will be something like this. Which is the common tangent we have to find. This equation we have to find. Now the common tangent, suppose here the point of point we take as P1, here you can take the point of point as P2. This point we take as a point of point which is P1. Now here if we compare with 4ax, what we get? 4a equal to 32. So a equal to 8. So this point can be written as 8t square comma 16t. Now this point P2. Now this we can write as, if we compare with 4ay, a is 1. So this can be written as 2t comma t square, obviously any other t, because it cannot be the same parameter. So this is the 2 point of contact we have got. Now if we take a tangent at this point of contact, they are immediately the same tangent if there is a common tangent. And then we can compare the two tangent equation and we can get the corresponding result. So to get the equation of tangent at this point, we have the point of point, we have to differentiate this curve. Why? The slope of the curve at this point and so the tangent at this point is same. So on differentiating equation 1, on differentiating equation 1, we get 2y gdx of y equal to 32. Now this gives us gdx of y equal to 16 by 1. Therefore, gdx of y at 8t square comma 16t equal to 1 by 2. That is the slope of the tangent at this point. Therefore, equation of the tangent. Therefore, equation of tangent at 8t square comma 16t, that is at P1, is y minus y1 equal to m into x minus x1. Now this one simplification we get ty equal to x plus 8t square. Now this is the first equation which we have got at the point P1. And we mark this as equation 3. Now we try to draw a tangent at this point, while we know the point of contact. So for to get differentiate equation 2. So on differentiating equation 2, we get x by 2 equal to gdx of y. Therefore, gdx of y at the point of contact 2t1 comma t1 square will be equal to t1. Therefore, equation of tangent at 2t comma 2t1 comma t1 square is y minus t1 square equal t1 into x minus 2t1. And that gives us y equal to t1x minus t1 square. And this we mark as equation 4. Now equation 3 and equation 4 represent the same node, same tangent. Equation 3 and equation 4 should represent the same tangent. So you can compare these two equations. So comparing with equation 3, we get, that is, we are comparing equation 4 with equation 3. Now when you compare, we'll get here 1 by t equal to minus t1 by minus 1 equal to t1 square by minus 8t square. Further simplification, 1 by t equal to t1 equal to minus t1 square by 8t square. From this one equation gives us t1 equal to minus 8t square and t1 square equal to minus 8t. Now squaring equation 5, we get t1 square equal to 64 t to the power of 4. Now using equation 6, we write minus 8t equal to 64 t to the power of 4 using equation 6. Now from this 8t into 8t cube plus 1 equal to 0. Therefore, t equal to minus half. Hence, equation of common tangent is minus half y equal to x plus 8t square. So y equal to minus 2x minus 4. So y plus 2x plus 4 equal to 0. It's the equation of common tangent. Here we have to find the common tangent to the hyperbola whose equation is given. Now equation of hyperbola, x square minus 2y square equal to 4. This one which marked as 1, and equation of circle, x square plus y square equal to 1. Now here if we draw the diagram, this is y, this is x, this is x prime, this is origin, this is y prime. Now this is the hyperbola and this other. So this is the hyperbola which you have got, whose vertex at the point 2, 0 and a prime minus 2, 0. Now circle x square plus y square equal to 1. So you can take a circle here. Now we need here common tangent. So for common tangent, this can be common tangent. Similarly, here also you can have a common tangent. You can see here that like this you can have a common tangent to the hyperbola. So at first what we do, we'll find the equation of tangent to the hyperbola. Now hyperbola any arbitrary point can be taken as a sector or b tan theta. So for that we have to bring the equation of hyperbola in the generalized form x square by 4 minus y square by 2 equal to 1. So here a is 4, a square is 4 and b square equal to 2. So the any arbitrary point would be 2 sec theta comma root 2 tan theta. So you got the point of contact. Now we'll find the equation of tangent. Further, you have to differentiate the curve because we know slope of the curve at the point P equals to the tangent at the point. So on differentiating equation 1 with respect to x, we get 2x minus 2 into 2y dx of y equal to 0. Now from this we get dx of y equal to x by 2y. Now slope of the tangent, so the curve at this point, we can just put the point of contact. So this gives us dx of y at 2 sec theta comma root 2 tan theta. We get this as sec theta by root 2 tan theta. So this is the pointer, this is the slope we have got at the point of contact. This is the slope of the hyperbola at the point of contact. That is 2 sec theta, here sec theta by root 2 tan theta. So this is the slope which we have got. Now if we simplify, we can simplify this one, and without that also we can proceed here. That equation of tangent is y minus root 2 tan theta equal to sec theta by root 2 tan theta into x minus sec 2 sec. Point of contact is 2 sec theta comma root tan theta, so they are substituted. Now we can simplify this. So on simplification, what we get, root 2 y tan theta minus 2 tan square theta equal to x sec theta minus 2 sec square theta. Now this one further simplification gives us x sec theta minus root 2 y tan theta equal to, because 2 common sec square theta minus tan square theta is 1, so we get ultimately 2. So this is the equation of tangent which you have got. This is the equation of tangent which you have got at the point P. Now when this is the tangent, now we know the distance of the tangent from the center of the circle. Distance of the tangent from the center of the circle is equal to radius. Now we can utilize the concept. So distance of the center of the circle the center of the circle from tangent is equal to radius. So you can write here 1 equal to minus 2 by root over of sec square theta plus 2 tan square theta. Now this one further simplification 4 equal to sec square theta plus 2 tan square theta. Now sec square theta is 1 plus tan square theta, so it is 1 plus 3 tan square theta. Very simple, just what we have done. Here just we have written that sec square theta is 1 plus tan square theta. We have simplified, we have got this. Now this gives us that tan square theta is equal to 1. Tan square theta equal to 1 means sec square theta equal to 2. And therefore sec theta equal to plus minus root 2. So here we get possible values of theta. Possible values of theta as pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. And the corresponding equations of common tangent. Corresponding equations of common tangents are as follows. First one we get, that is x minus y equal to 2. Second one we get minus x plus y equal to 2. Third one we get minus x minus y equal to 2. And the fourth one gives us x plus y equal to 2.